Fun, fun and remember. Bro. Good morning, ladies and gentlemen. How are we doing today? Wonderful, excellent, amazing, incredible, ladies and gentlemen. Put away your phones, put away your headphones. If I see them after now, I will have you put them in the cabinet or take them down to the principal's, whichever one you prefer, ladies and gentlemen. All righty, you need to get your computers out. You need to get logged in. You need to come up and you need to grab a piece of scratch paper and take out a pencil and your calculator for the start of class today. So let's do all of that stuff, ladies and gentlemen, while I get attendance. Oh. No scratch? A, B, C. I hate him so much. Dude, I feel so bad. You know, wait. Yeah, you know, he yells at you a lot. Even when he's trying to say, yelling at you, I just want you to learn, like, you're yelling. He should just retire.
Josh. Achilles, Shamsa.
No, 25. Yeah. 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 If you're in a 30, no, if you're in a 25, you're gonna want to do 25. But you know who you should have listen to? She also works with ABC.
Okay, ladies and gentlemen. What would the R value be for a standard unit of pressure of 29.58 inches of mercury? You don't see anything? Try opening your eyes. Now, you may not have saw that until I just hit that button, but you should have seen something. So I want you to calculate what the R value is if your standard pressure is 29.58 inches of mercury. Go.
Are we supposed to be in a physics?
You don't have to. This is the question, but it really, you can't do the calculations in the Pear Deck, so I was going to have you do that, but it makes more sense for me just to show this to you and have you answer it. Yes, sir, Joshua. It's supposed to be inches, yes. It's a different unit of pressure. So it is supposed to be inches, definitely. What's right here? You have to calculate it, ladies and gentlemen. There's a few ways you could calculate it, but you have to calculate it. You can't find it based on the numbers that I gave you the other day. You can do it based on the formulas that I gave you the other day where I showed you how to calculate R values, but you do have to calculate it.
You can taste it on your lips.
It's just.
Bro, they literally did not teach us any of this stuff. What is this?
Anybody got an answer for me? Wouldn't surprise me for a question exactly like this to be on your test. Well, you should know how to do it.
2.43.
What do you got? 2.43 unit.
2.43 inches HG
Inches of HG
over mole times K.
Okay. Anybody else? Okay, let's begin with the basics. What formula do we need to use? Wow, we are in trouble. What is the only formula we have that involves the the R? PV equals nRT. If we are going to solve for R, we have to put a number in for P, for V, for N, and for T, correct? Okay. Well, let's put in a P. What would be our pressure? 29.58 inches of mercury. Okay, what's our V? Only one value we ever use for V under standard conditions, ladies and gentlemen. What is it? 22.4. Oops, sorry. Equals, what do we put in for N? What's our value for N? 1 mole. R is what we're solving for, so I'm going to leave that. What do we put in for temperature?
273.
So how is this a problem solving this, ladies and gentlemen? You've got an equation where you have one variable. What do we do to solve for it?
You get the variable to one side.
We isolate the variable. Yeah, get it to one side, isolate. I don't care how we say it. That's fine. We try to get R alone. How do we get R alone?
You divide. What you do to one side, you do to the other.
Okay, we divide R by what?
1 mole R 273K.
1 mole and 273K.
And then those cancel out. And then what you do to one side, you do to the other.
1 mole,
You know?
273K. Here's our units, inches times liters over mole times Kelvin. Do we have someone else who could do the math real quick to confirm what Shenza gave us of 2.43? Yes, no, maybe so. Yeah?
Yes.
So all we have to do to solve for any R value, ladies and gentlemen, is put in all standard conditions. There's only one standard condition that ever changes. What is it? Pressure. The rest of this formula does not change at all. This changes because of the different units of pressure. We will never use anything for volume other than 22.4. We will never use anything for mole other than 1. We will never use anything for temperature other than 273 Kelvin. So you can do this way.
Can we do another one?
No, because we're going to do this one a different way first. Because the nice part about chemistry is there is more than one way to solve a problem. More than one way to solve a problem. So we're going to do this a different way. What? No, we're not. We're going to use, oh my God, math. Someone give me an R value. Any R value. I don't care what it is.
1.
What's the R value for, Phoebe? And Phoebe,
Yeah.
there's a pressure that goes along with that, isn't there?
Yeah.
What is it?
101.3.
What did I set up here, ladies and gentlemen? What's this called in math? No. It starts with a P. A little bit of math will go a long way in your life, ladies and gentlemen. This is not hard math. What is this called? When you have one thing that is equal to another. Give you a hint. We've been doing it with Boyle's law, Charles' law, Gay-Lussac's law.
But, class 1.
That's not what this is called, though. You're telling me how to solve it.
It starts with a P.
Starts with a P. When one fraction is equal to another, they are what to each other?
Perpendicular?
No, perpendicular.
Product.
What word are we looking for here?
Proportional!
Oh! I had a
Proportional!
perimeter.
In other words, the ratio of these two numbers should be equal to the ratio of these two numbers. Right?
Yes.
Now, where did I get this from?
The other problem.
Problem.
The problem. It's the pressure.
Yeah.
Where did I get this from?
Standard.
Okay. So, I've got these two set up. This is in a certain ratio compared to this, correct? Which would mean that their R values should also be proportional. So, I put the 8.31 down here. Why? I don't have to go through and I don't have to calculate everything in R values now. I don't have to put in pressure, volume, temperature, amount of gas. I can simply set these two things equal to each other because they should be proportional. If the values of the pressure are proportional, so should their R values. Now, how you solve this? Now, Shenza, what do we got to do? Cross multiply. Same thing we did in Boyle's law. Same thing we did in Gay-Lussac's law. Same thing we did in Charles. Same thing we did in Avogadro's. Again, ladies and gentlemen, a little bit of math goes a long way with your science. No math probably means you're going to suck at science. Okay? So, X times 101.3 kPa is equal to 29.58 inches of mercury times 8.31 kPa. Isolate our variable. Divide this side by 101.3 kPa. By the way, I should have here, there's more to this unit than just the kPa. Sorry. Let me add that in. You don't have to write it. I'm not going to grade it as an intermediate step. Okay? I will not do that. Okay? But it's going to help us get to our final unit over here. Now, again, if you don't want to write the units, you don't have to. But if you make a mistake because you didn't write the units, well, that's on you. Okay? In the end, if you want to go back and add the units, that's fine. I always like to put units in because I want to see them cancel. I want to see all those things. Okay? So I'm going to divide this by 101.3 kPa. Now, the only unit that cancels out of all of this is kPa. And this is how I'm left with inches of mercury times liters over mole times Kelvin. That's how I'm left with this unit. Now, if you solve 29.58 times 8.31 divided by 101.3, somebody tell me what we get for that mathematically. Doesn't matter how you do it, ladies and gentlemen. You're going to get the same exact answer either way. Either way. Now, you may find it handy to use your math occasionally, to use previous knowledge, to use things you've learned in this class, because we're going to start not only giving you gas laws, but you're going to have to start applying them and using them. And it's going to be more than just plug in these numbers and chug through a problem, which we sometimes struggle with. But science is more than that. Phoebe, what can I do for you?
Let's say we use ATM instead of kPa, we would have gotten the same thing.
You would have gotten it whether you used ATM, MMHG, whether you used PSI. It doesn't matter, because this number would have changed, so would this one. They would still be proportional, because the only number that is changing in PV equals nRT is the pressure. Okay? Is the pressure. So therefore, ladies and gentlemen, the R values, the reason that one is 62.4 is because it goes with the biggest pressure number, 760 mmHg. The reason that there's one that's 0.0821
is because it uses the littlest value, number value for pressure, 1 atm. But the ratio of 760 to 1 is the same as the ratio of 62.4 to 0.0821. Okay? Take 62.4 on your calculator, divided by 0.0821. You should get 760.
Yeah.
That ratio always holds. Now, if you use a different unit of pressure, maybe it's 14.7 to 1 because it's PSI to ATMs. Their R values are still proportional. The R value for PSI is 14.7 times bigger than the R value for atmospheres. Okay? So that's what we're saying. Question. Now, I will do a couple more problems with you. I'm not going to do this one again because take out your packet and let's do a couple of those, ladies and gentlemen. Now, I went through the packet after you left, ladies and gentlemen. Some of these problems we can do, some of you will not be able to do until next week. What day is today? Till this week, Friday. Okay? Some of you will not be able to do until this week, Friday. And that is why, ladies and gentlemen, some of them are going to be a little bit more challenging, but we'll go through those. Now, before we go any further, today we're going to work on ideal gas law and other gas law problems out of our packet. And I'll tell you which problems you can and cannot do. I will be able to understand and use ideal gas laws to solve problems. Not just solve a problem in ideal gas laws, but use that law to solve other problems. Susie.
Did we have our lab today? Or?
We were supposed to, but since we didn't have school yesterday because we stayed at home because there was no snow until long after we would have been home at the end of the day anyway, it got pushed back till tomorrow. Okay? So you will need your goggles tomorrow. Again, I have the ones you had in class. You need to bring them if you don't have them here. The test is coming up next week. It was supposed to be on Wednesday. It'll be on Thursday of next week. Excuse me. Hello, Mr. Brand.
90 degrees.
Yes. No. How did you post it? Okay, but when you posted it, did you copy and paste the editable version, or did you go to the actual quiz and copy and paste the link where it says start quiz?
That's like version. I think we should actually have a version.
So like if you open up the test, then go to the preview button, and that's the link you want to post. It always did for me, but then okay. So then when you're doing it, make sure that you. What I do is I star the quiz because I do it in class. I star it so that it's one of the stars, and then when I do the Google Drive, I hit that. I can find it easier. Just to make it easier to find, and then you should be able to put the lock mode in. If you can't, then there's for some reason they're getting an editable copy of it.
Yeah.
Okay. Okay. Thanks. Bye. Okay. So, ladies and gentlemen, retakes. It is the 16th is not Friday. The 16th is next week, Tuesday. So you got till the 16th if you want to do a retake on Unit 5. Last day for it. All corrections must be in ahead of time and show them to me. Then you can do it up until that day. The test will be next week, probably Thursday. Okay? Just so you know, just so that you're aware of it. Okay? All right. So in your packet, ladies and gentlemen, you cannot quite do 1, 2, and 3 yet. You cannot do 1, 2, and 3. You can do number 4, so you may want to circle it. Did we do 4 together?
No.
Okay, that's the one we'll do then in just a moment. You can do number 6. You can do 7 and 8. You can do 10, 11, and 12. You can do 14 and 16. You can do 19 and 21. You can do 24 and 27. Okay, so let's begin with number 4, ladies and gentlemen. Okay, so we read the problem. How many grams of methane can fill a container, a 20-liter container at 65 degrees and 739 millimeters of mercury? Now, there is a reason I gave you the formula for methane there, ladies and gentlemen, because we have never given you any way of naming or writing a formula for that compound. We didn't do those. That was a binary covalent compound. Methane is the more common name for it. I would have had to have named it what for you to be able to write the formula? Look at the formula for methane. Tell me what the other formula for it would be.
Carbon tetra.
Thank you.
Okay, you've come 90% of the way, Phoebe. Finish it off correctly. Thank you, Morgan. Remember, all compounds, ionic or covalent, that are binary have to end in IDE. So hydrogen becomes hydride. So carbon tetrahydride, okay? Also known as methane, which is what you produce when you fart, ladies and gentlemen, okay? So how many grams of it? All right, so let's go to the problem. Not that one. This one here. Boom, boom, boom. Okay. So this is the problem that I need, ladies and gentlemen. All right. So here's our problem. I just moved it onto a different screen so that I have a little bit more room to work with it. Okay, so what information do I have in here? What information do I got? Okay, we got a volume. What is it? 20.0 liters. Okay, what else do we got? Temperature, what? 65.0 degrees Celsius, which is what? 338 Kelvin. Good, because we need to convert it. And what else do we have? Okay, so what gas law do you think we're going to use? Well, let's ask this. What are we solving for? Grams. Okay. What can we relate grams to? Which is what? N. So we've got a P, we've got a V, we've got a T. We need to solve for N. What formula should we use? PV equals nRT. Now, here's what I will tell you. Maddie, you suggested possibly using combined gas laws, right? You could do this with combined gas laws. There's more than one way to solve this problem. Combined gas laws could work for this, okay? Again, it would probably be a little bit more work than doing this, though. All right? So we are going to solve for N. We're going to put all these in. So I need an R. Which R am I going to use, ladies and gentlemen? And why?
The 62.4, because it's the same unit as
Because it's mmHg times liters over mole times Kelvin. Absolutely correct. It's the same unit in pressure in both of these. So now, plug in our pressure, 739 mmHg. Plug in our volume, 20.0 liters, equals N, okay? We're solving for N, so we're going to leave that. Our R value, 62.4 mmHg times liters over mole times Kelvin. And again, as Maddie asked me earlier, do you need to write all these units? You don't have to. I'm not grading you on it. But you better make sure you end up with the right answer in the right unit when you're done if you're not going to show me any units. And our temperature is 338 Kelvin. Now from here, ladies and gentlemen, you should be able to take this problem and finish it up. You have got a problem where you have one variable. We need to solve for one variable. We do the same thing every time. We isolate that variable. We want to get that variable alone on its own side so that we can solve for it. To do that, ladies and gentlemen, since I'm supposed to multiply n by these two numbers, I'm going to take it, I'm going to divide this side by these two numbers. These cancel. What I do to one side, I have to do to the other. Now again, since I bothered to take the time to put the units in here, I'm going to make sure they cancel. Kelvin and Kelvin cancel here. Millimeters of mercury and millimeters of mercury cancel here. Liters cancel here and here. The only unit I'm left with is moles, which is good because that is what I wanted from N. Now, can someone please do the math and quickly get me a number to 3 sig figs, because 3 sig figs, 3 sig figs, 3 sig figs.
0.701.
Okay. 0.701 moles
Yes.
of CH4. Good, because I still need that CH4. Because I want this to be in what unit? Grams. So now I'm going to take something that we used in the last unit, something that we learned in the last unit, and I'm going to use it in this unit. I'm going to use formula mass. Now, carbon is 12.00, hydrogen is 1.01, so that means 16.04 grams is equal to 1 mole. Mole and mole will cancel out here. Take 0.701 times 16.04. Should be about 4. Okay, good.
Grams.
CH4. Perfect. Questions?
Can I go to the bathroom?
Go ahead. I'm just going to show you how to do this another way. All right. Now, what I would like to do is work this problem, as you said just a minute ago, Maddie, in P1, V1, T1, and combined gas laws. Okay? So for combined gas laws, we're going to use P1, V1, T1. Oops, sorry, wrong number there. Equal to P2, V2, T2. Okay? Now, for us to do this, ladies and gentlemen, we need to know which of these variables is grams related to. Which of these variables, P, V, or T, would grams be related to? No. We have no law that relates T and N. Which one do we have that relates something to amount of gas? N. Which other variable is related to it? Which gas law? Avogadro's. And actually, I don't need Avogadro's whole law. Because if I know the volume of a gas, I can figure out how many moles there are, correct? But the only way I can use Avogadro's law is under what conditions? The only way I can use Avogadro's law is under what conditions, ladies and gentlemen? More than staying constant. Has to be under what conditions? Come on, we learned this last unit. What does Avogadro's law have to be in to use it? What conditions? What are the only conditions I've given you that always have to be? STP. We're going to use that. We're going to use that, okay? So on one side, I have a pressure, a temperature, and a volume, don't I? I have a pressure, 739 mmHg. What's the volume that goes with that? Come on. What volume goes with it?
2.4 liters.
No. 20.0 liters. Do I have a temperature that goes with this?
It's the 338.
You bet. Now, what I'm going to compare that to is P2, V2, T2. I don't know what V is because I don't know how much gas there is here. But I can put standard pressure and temperature in for these. What's standard pressure? What standard pressure do I need to use? 760 mmHg. I'm going to solve for volume. I'm going to solve for volume because it will relate to the number of moles, right? But only when you're at standard pressure and standard, which is? So now we could solve this, ladies and gentlemen. We are again going to do cross products are equal. Again, I'm just showing you another way you could do this problem. 739 mmHg. 20.0 liters. 273 Kelvin. Equal to 760 mmHg times V2 times 338 Kelvin. Now what do we do? Get the variable by itself. So divide this side by 760 and divide it by 338 Kelvin. Very good. Kelvin cancel. Millimeters of mercury cancel. I am left with a volume. Calculate what the volume is. What is it, Josie?
0.701 liters. And then converted into grams. Oh wait, do we have to?
No, that's not correct. You didn't do the math.
I didn't.
You didn't do the math. You gave me the same answer as the last page.
Did. We didn't. No.
I need someone to actually do the math. Anybody else get that? 15.7 what?
Liters.
Liters. Now that isn't what we wanted, is it? But this is 15.7 liters at what conditions? At STP. Which means, how do we get from liters to moles at STP, ladies and gentlemen? Using
The thing we learned last week.
what?
The thing we learned last week.
Which was what?
2.4 liters.
Equals 1 mole. What goes where?
The mole on the top.
1 mole on top, 22.4 liters on the bottom. Now do that math and tell me what you get. There's your 0.701, Josie. But it's moles, not liters. I don't care which of the two formulas you use. I just did 2 different formulas, solved the same exact problem. Got the same exact answer. Now, I haven't converted that to grams yet, correct? But you want to work this problem using combined gas laws? You absolutely positively can. But the only way we could do it is the relationship then for grams of methane is to moles still, but moles relates to volume at STP. Well, let's solve for volume at STP. That's what we did here. Okay? On the other one, it already took into account the volume and stuff at STP because it put in the R value for us. You can do either one. I don't care. Either one. Questions? Okay. Let's do number 7. Okay, ladies and gentlemen, you tell me, what do I need to solve this?
Formula math.
Huh?
Oh, not that. Like, so,
Well, what are we trying to find?
density,
So you tell me what we need.
pressure,
How do pressure and volume affect density?
mass.
What?
Nice.
And you did it in this class, ladies and gentlemen. You found density.
I remember.
Why?
How do we find density?
Mass and volume.
Density equals what? Mass divided by volume. Now, you also need to remember something else we taught you about density. Something that the lab we did taught us about density, even though we had 4 different sized objects, even though they had 4 different masses, even though they had 4 different volumes, what was their density? Not maybe the same. It was the same. Which means density does not depend on what? What does density not depend on? Whether it's a small object or a large object. It doesn't depend on what? It doesn't depend on the amount of object. It's an intensive property. It doesn't depend on the sample size. You know why that's good for us, ladies and gentlemen? You pick the sample size. How big a sample size do you want to use? Yeah.
One.
What?
One.
One what? Well, you got to give me something. One. Hey, I want one, Mr. Man. I want a sample size of one. One what?
1 mole of
Why not do 1 mole of neon? If we do 1 mole of neon, what do we know about neon? Or at least 1 mole of it. Come on, people. Apply what we've already learned. What do you know about 1 mole of neon that would help us determine a mass or a volume?
It's 20.18 grams.
20.18 grams equals how much?
1 mole.
1 mole.
of neon.
Okay. So if we're going to assume 1 mole, what can we use for mass here? We can use 20.18. What do we use for volume?
22.3.
Why?
Because it's the standard.
What?
Isn't it not the standard? Please?
Well, are we at STP?
Yeah.
And the mole of any, or the volume of any mole of gas is how much? 1 mole of gas, doesn't matter what one, equals 22.4 liters. Take 20.18 divided by 22.4.
0.901 grams per liter.
There's your density, ladies and gentlemen. Sorry, I should have put grams here. At STP, assume 1 mole. Why? 1 mole gives us the mass of a substance. 1 mole also gives us the volume of a substance at STP, right? The volume is 22.4. The mass is the formula mass. Any gas that is at STP, the only thing in this formula that changes is what? The mass. We use hydrogen gas instead of neon. We take and put in the mass of hydrogen, 1.01. Divided by 22.4, because that's how much space 1 mole of hydrogen gas is going to take up. You can find the density of any gas this way, ladies and gentlemen. Now, do number 8, but I will tell you this. What's the problem with number 8? Not at STP. But we still want to assume 1 mole. Multiple ways of solving it, ladies and gentlemen. See what you and your partner can come up with. Let's go. Right? Number 8. We just did number 7. You do number 8. You cannot, in this problem number 8, assume that the volume is what? Why? Because it's not at STP. You cannot assume the volume is 22.4 because you are not at STP. That's a good start. You better go somewhere from there, though. Here's the one thing I would tell you. I would again assume 1 mole. Because 1 mole will get us what?
What will 1 mole get us in that problem? Mass. That's halfway home. Now all you need to do is find out what the density is, or the volume is. Multiple formulas you can use, but you got to find one formula to solve for volume.
Oh yeah. That's for the. I'm assuming that's for the ones. So it'd be. Okay, so just. I'll push 16 plus.
No. Well, okay, wait. It can be. Keep going. Keep going. Here's the one problem with this one. So what do you I like what you said.
Yeah, it's the part that I'm still using it.
I'm just thinking, like, what if it's one of these that we have to use?
Well, that's also not
Or they. Oh, that would
It's not even STP though.
keep going. You are right on the right track.
It was a sugar.
Come on, what formula are you going to use to find volume? Like, you know how like the okay, so what do we use to find volume when it's not STP?
Because it is.
Well, look at the top of your sheet and see what formulas you have available to you.
Temperature, but then you scale
Yeah, so we should do
That's what I'm thinking. I should have wrote that down.
You're gonna get something now at least. Get the mass down, get the volume down, get something down.
Let's combine gas down, right?
If you're looking for a formula to use, don't look on your periodic tables, don't look at that. Look at the top of the worksheet that you're looking at on the first page. There are all our formulas for gas laws there. You got to use something from there. Something from there. And I'm telling you, there are multiple ways of working this problem. Multiple.
Yes.
Oh my god. We're good now.
So, did you do anything with this here? No. So this is what.
What is it?
So you're using Boyle's law. There's one problem with Boyle's law. So the law temperature would not change, right? Okay. This is the temperature at what conditions? Not standard. So therefore it's not. So you're full. What? No, because then you're not at standard pressure. See? You could. Yeah, no, you could. I've seen other people do it different ways, but very good. Finish your math.
Hey.
Don't look at Phoebe's. But you two are going to do the same problem two different ways. And if you ignore math correct, you'll end up with the same.
Yeah, I don't think combined yes.
Okay, so
Don't set up and get my math right.
It's the same thing.
Do not.
Pressure.
Okay, that's right. We're good. Finish it out.
It's the same thing.
I know, I can never tell anymore.
Okay, well, this one we did the opposite.
Use this to get the volume.
One more. I'm assuming.
Solve for
Exactly. That's on the other side.
Oh, and then.
Oh my God.
we just use, yeah, we could just
For what?
Yeah, it's like oh my God.
Those two are related. Those two are equal. But I, in that formula, he's allowed to for me to use that R value. R value incorporates in one mole or something. Okay. How are we doing? Can I see yours? Yeah. No, that's fine. Jasmine, can I see yours?
I don't have anything, I erased it.
Okay, yeah, it's not that much. So what we, how do you know?
What did you get, 23?
Okay. I like what you're
Yeah.
Pressure.
Yeah, we just
Standard volume.
did it weird ways.
Okay,
but
down here.
I'm fine.
So just go on.
Yeah. Standard pressure. Standard volume.
I was gonna say, whenever it's a gram stuff,
How am I
for
gonna
the
remember all
I need to know what they mean, like,
Because how am I gonna know?
Which formula?
I know,
Which
which
formula do you want to use?
How much is the one that is? I got two.
Well, which are the ones that solve for volume? Which ones could you use to solve for volume?
I have one.
I have to read six and stuff. He was like, liquid now, it's not an like the grams. I saw that.
Right. It's values, right? This one.
And everything cancels out. So
Okay. Now remember, how much are we assuming?
the only thing that we were left with was times.
In the problem, we need to assume how much of the sample there is. Doesn't tell us, so we can assume it. How much are you gonna assume? In the last problem we did, in that problem, he said, we don't know how much samples there. It doesn't tell us, so we're gonna assume how much. And it doesn't matter because density is an intensive problem. You can pick any sample size you want. What's the easiest sample size to pick? How much?
I think
One what?
I think.
One mole. So pick one mole.
Yeah, when you put volume, I got it.
Okay?
Mr. Brain, is this right?
Did you get him on track? Good luck. How we doing?
Good.
Okay, can I ask how you got that?
Oh yeah, I did it right there.
Where you going?
It's a little messy, but I did it.
Dude, I don't, I'm maybe really distracted because I
And
know.
how did they follow what he did?
So scared.
All right, ladies and gentlemen, most of you have done really well on this, so we're going to go through this with you. Two different ways of solving the same problem, ladies and gentlemen. Two different ways of solving the same problem. Okay? And I watched two people right next to each other solve the problem different ways and get the same answer, and that is the coolest thing. because that's the cool thing about this, ladies and gentlemen. How you go about doing this is up to you, as long as we get the correct answer. So here we go, ladies and gentlemen.
Wait, are you gonna demonstrate both ways of doing it?
Sure.
Okay.
Sorry.
Oh.
Okay. So ultimately, to solve for density, what do we need, ladies and gentlemen? Mass and volume. So for density, we always need mass divided by volume. And again, since density does not depend on the size of the sample, what is the best assumption to make for the size of a sample? 1 mole. Why do we want to assume 1 mole? Because it gives us the what right away? It gives us the mass. The mass then becomes the formula mass. If we are assuming 1 mole of carbon monoxide, we can say that 1 mole of carbon monoxide has a mass of 28.01 grams, correct? Do I need to show anybody how I got 28.01? And that's the number that is going to go in here. So density is equal to 28.01 grams over a volume. Now, what 2 formulas do we have to solve for volume? PV equals nRT. And what other one? What other one? Okay, what do we call that one instead of just going that P1 thingy through combined gas laws? Okay, so let's do it with PV equals nRT first, ladies and gentlemen. So, what was the pressure from the problem? 115 kPa. We are solving for volume, correct? So we're going to leave that V. What do we use for N?
1 mole.
1 mole. That's the other reason that we want to assume 1 mole. It fits into this formula. Now, what do we use for R? 8.31. Okay, and then what do we use for temperature? 323 Kelvin. Okay, do I need to show you how we need to rearrange this?
No.
So ultimately our volume becomes what? 23 point what?
3.
Good. Questions? Okay, so down here, okay, I've only got a temperature and a pressure, correct? Okay, but I'm going to solve for what? Volume. Because that's what I need for here, right? So what conditions can I compare it to?
No.
Yes. Yes.
Yeah.
Yes, we can always go back and compare things to STP. Now, P1 is 115 kPa. V1 is going to be unknown. And I picked that side. It doesn't matter which side we pick, correct? What is T1? 323 Kelvin. Okay, so now this side I'm going to use STP, correct? Okay, so what's our pressure? What?
I don't know. I was thinking of the wrong.
Nope, that's fine. What would our pressure be? kPa. Standard pressure, what is it? Isn't it? No, isn't it? What is the damn number?
101.3.
There's no isn't it. We're not debating this. It's a number. It's the same number all the dang time. Good. What's our standard volume? 22.4. 22.4. Nope, not even close. What's the standard temp?
7. My bad. 273.
And we could solve this for volume, correct?
Yeah.
Okay, stop. Someone punch these three numbers, this whole side, into your calculator and tell me what you get.
$8.31. There it is.
That's your R value, ladies and gentlemen. What's the one number that's missing in here?
Oh.
Hey! What is the one number that is missing in here? P, V, T. What is N? No!
That's one.
One!
Yeah.
We assumed one mole. I don't give a care which one of these you use because you're doing the same math either way, ladies and gentlemen. This comes out to be this. That comes out to be 8.31. I don't care if you use PV equals nRT or if you use combined gas laws. You're going to do the same thing. Questions? Good. Go to work, ladies and gentlemen. Oh, man, we don't have much time. Not much time. Wow, tomorrow when we do the lab, we're going to find out if you actually understand what we're talking about.
We're not going back to 6. We're going back to 6.
Well, how did you get 29 from
I don't know. I was just saying, Angle is my pencil, so we all have the same time.
I hope you paid attention, 90 degrees. Otherwise, I'm going to start having to call you an obtuse angle.
Yeah, I got it.
No one's ever accused Angel of being cute. I will be here till 3:45.
How do you get 2.02 Getting real tired of it. See, that's why I don't want to do that.
You know, I think TV equals nRT is the like the formula we use. Like besides the equation for why like or what is it? The one that's like opposite of the square root of
Oh, we have to. I keep forgetting that we don't need.
At least he keeps forgetting what he remembers.
Exactly. Doesn't make sense. We know it's Wednesday. Not Monday.
Oh my gosh.
Wednesday.
It's Wednesday?
Yeah.
I feel like I've only been in school 2 days this week, though.
But it feels like a Monday. Like I'm not locked in.
Oh my god, I did a stupid part again.
Really? That's what I heard. Like it's gonna be like that. It is something else.
How are you doing this one? I don't follow.
Because this one's easy.